So let's continue where we left off with the binomial expansion theorem. You're going to need your graphing calculators out, of course. You're going to want to have them in the choose mode. Brandon, you're going to show Caitlin where that is. The only advice I would give you, my grade 12s, when I used to teach this back in Principles of Math 12, the advice that I have for you, they would try and get clever and try doing steps in their head. It is so easy to make a dumb mistake in this. This is one time you'll notice, as much as I love shortcuts, I ain't taking them. So example E says, write the first 3 terms of that expansion. Is that a binomial? Is that 2 terms in the brackets? Yes, so we can do this. But how many terms does it want? It wants us to write 3. By the way, Sean, what's the exponent?
5.
How many terms are there? Not 5. 6. Why? Because remember, we start counting with what? With a 0. Okay? By the way, Sean, in F, how many terms are there going to be? What's the exponent? In F, what's the exponent?
6.
How many terms are there going to be? 7. Yes?
Yeah.
We're adding 1, right?
Yeah.
Because we start counting where? At?
0.
Okay, you with me? You with me?
Yes.
Okay, let's go back to E. I have to jog your memory. You weren't here. How many terms does it want me to write out? 3. Oh, so I'm not going to write out all 6. This is probably going to be much more similar to the question you're going to see on the test. I'm going to give you a big exponent, but if I give you a big exponent, I don't want you to write out every single term. I figure if you can write out the first 3 or 4, you've convinced me you've spotted the pattern. In fact, usually it's write the first 4 terms, and I either make it worth 2 marks, half mark each, or I make it worth 4 marks, 1 mark for each term. You with me? You with me?
Yes.
What's the great big exponent? In E, what's the great big exponent? What's the exponent outside the brackets? What's the exponent?
5.
Okay, ready? Scene 1, act 1, take 2, look intelligent. What's the exponent outside the brackets?
5.
Write this down. So we called this n. So write down, hey, n is 5. Write that down, Justin. Seb, stay with me. Sean, what's sitting where the letter A was last day?
2x.
Thank you, Sean. What's sitting where the letter B was last day?
3y.
Nope.
No. Negative 3y.
Negative 3, come on in,
Negative 3y.
y squared. I'll get you later. Yes? 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 Then shush. Okay. We're jogging our memory. We're back, folks. We've recovered from the weekend. We're thinking here. What's the great big exponent?
5.
5. So how many terms do they want me to write? It's going to be 5 choose 0, 5 choose 1, 5 choose 2. There's the first 3 terms. Yes? Oh, and it's going to be a to the, what's the great big exponent? 5a to the 4th, a cubed. A squared, a to the 0. Don't freak out. They saw this. Just kind of follow along and see if you can figure it out. We'll get you caught up later. Yes?
Yes.
No problem.
Yeah?
My calculator is good.
Like the batteries? Okay, I'll get there in a second. B to the what?
B to 0.
0, then 1, then 2. Right? Oh, and your built-in error check was each time if you added the exponents on the A and B, Sean, what's 4 plus 1?
5.
What's 3 plus 2?
5.
What's 5 plus nothing? 5. So there's your error check to make sure you're not missing anything. The exponents always added to the great big exponent outside the brackets. The reason I called it, because there's 2 exponents. There's a squared there, but when I say the great big exponent outside the bracket, that's our n that's defining this. Okay, now let's start to plug stuff in. On your calculator, oh, we've got dead batteries, so let me see if I can have some new batteries. I don't know. Let's find out. So we said 5 choose 0, 5 choose 1, 5 choose 2, because of the exponent, Sean, yes? A to the 5th, A to the fourth, A to the third, B to the none, no B, 1, 2. All right, now let's carefully start doing our substitutions. So on your graphing calculators, what is 5 choose 0? Okay, so that's going to be a 1. There's going to be a to the fifth, except it's not an A. What's sitting where the A is? Okay. Plus. What's 5 choose 1? 5. There's going to be a to the fourth, but it's not an A. What's sitting where the A is? 2x. And there's going to be a 1. This is about the only time I do write the invisible ones. Normally, when there's a 1, you can't make me write it because I'm naturally lazy. This time, it's so easy to make a mistake, I'm going to be a little bit careful. Hey, what goes there? The B, except it's not a B. What's sitting there? Negative 3y. Oh, squared. Plus 5 choose 2. 10? It's going to be a 2x all cubed and a negative 3y squared all squared. Okay? Now, in this first term, this 2, which is actually a 2 to the fifth, that's going to become part of my coefficient. What I really end up with on my next line is a 1, a 2 to the fifth, and an x to the fifth, because that 5 goes on everything in the brackets. Is that okay, Brooke? What's sitting right here? I didn't square it, but what's sitting right here? So that 5 is going to go on everything in the brackets. It's going to be a 2 to the fifth and an x to the fifth. I guess, by the way, I could have put that 5 there inside the brackets for that better. But I'm saying that fifth goes on everything in the brackets. Is that okay? Plus, hey, there's going to be a 5 still in front. This 5 drops down like a domino. But can you see that 4 is going to go on the 2? I'm going to have a 2 to the fourth and an x to the fourth. And that 1 is going to go on the negative 3 and on the y squared. I'm going to have a negative 3 to the 1 and a y squared to the 1, which I guess is just y squared. So far, so good, as long as you're careful. Plus, the 10 drops down like a domino. Rosanna, can you see there's going to be a 2 to the third? And? X to the third? Oh, and? A negative 3 to the what? Squared? And then there's going to be, can you see it? A y squared squared. What's a y squared squared? Y to the fourth. We multiply exponents when we do a power to a power. So now we'll get out our graphing calculator, only I don't want this one. I want this one. And I need to be in my menu. I need to go option, arrow sideways, probability. Okay. So this first term here is going to be an x to the fifth for my variable. But this is going to make up the coefficient, a 1 times 2 to the fifth. A 1 times 2 to the fifth. I didn't really need to type the 1 times, but in the other ones I will need to type stuff, so I just wanted to show you that's what we did. It looks like the coefficient's going to end up being, okay, the first term ends up being a 32 x to the 5th. So far, so good, Erica? The second term, look at all the numbers. Now, in the second term, that's going to be part of the coefficient, that's going to be part of the coefficient, and that's going to be part of the coefficient. In the second term, the coefficient is going to be a 5 times a 2 to the 4th times a negative 3 to the 1. I didn't really need to put that to the 1, but I'm just putting it there because, you know, when there's not a 1, we have to include that. What do you get for the coefficient of the second term? Roy, what'd you get? Yeah? Yep. Anyone else? Yeah? So, you know what? It's going to be minus 240. Oh, it's not a plus after all. It's a minus, actually. And now I drop down the variables. X to the what? X to the 4th, y to the 2. In the third term, that, and that are all going to be part of my coefficient, the front part. The coefficient is going to be a 10 times a 2 to the 3rd times negative 3 squared. What does the coefficient end up being in front of the third term? 720. Positive or negative? Positive, which Silke tells me to put a plus 720. X to the what? Y to the what? X to the 3, y to the 4th. Oh, by the way, Sean, you'll notice once I start simplifying, my check of adding the exponents and adding to 5 doesn't work anymore. And the reason is I ended up going y squared squared. And I didn't just plug in a single letter, a variable in for a. I plugged in other exponents. That check of adding the exponents only works in my template, in my little system up here. But what did this question ask, Sean? Read me the question. How many terms?
3.
Okay, you know what the first 3 terms of the expansion of that are? 32x to the 5th minus 240x to the 4th y squared plus 720 x cubed y to the 4th. I like that question. I like that question. I like that question. I like that question. Why did I say that? You didn't hear me say that. Are you the kind of student that just notices those things when a teacher tends to emphasize certain stuff? Good for you. Okay. Oh, and you'll notice one of my terms ended up being negative. Actually, because I had a negative in my B, I'm not surprised that there should have been a negative tumbling through sometimes. Oh, but sometimes when you're squaring or fourthing, the negative would have vanished. F. Justin, what does F want me to write?
The last 3 terms.
Oh, the last 3. Okay. Justin, you with me? You good?
Yeah.
Can you keep?
I just got a negative 720.
Okay, thank you. Sorry, I should have pointed that out. You got a negative 720. I can tell you why. Because you didn't put the negative 3 with the exponent outside in brackets. And if you don't do that, if you type this, delete, your calculator, I said computer because that's what it is, it won't know that you want it to square the negatives. So whenever you're doing exponents, I tend to put the number in brackets and the exponent outside brackets. You don't always have to, but you do whenever there's a negative, so I just got in the habit of doing it all the time to be paranoid.
I just put the square in the bracket.
Nope.
Yeah,
Yep. Okay? Good question. Great question. Back to Justin. Justin, what's in example F, what's the great big exponent outside the brackets? What's n?
6.
Okay. By the way, how many terms are there then, Justin? Not 6.
2.
No, how many terms grand total? Folks, how many terms grand total? 7. Okay. Justin, read me the question again.
Write the last 3 terms of the expansion.
Okay, the last 3. What's my exponent? What's n?
6.
So I guess it would have gone something like this. The last term would have been 6 choose 6. The one in front of it would have been 6 choose 5. The one in front of it would have been 6 choose 4. Right, going backwards now. If I start with 0, I end with 6, so I'm going to go backwards. You okay with that, Justin?
Yeah.
Justin, what's sitting where the A is? Folks, what's sitting where the A is? 3x squared. What's sitting where the B is? 2y. Positive. Okay. 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 Question? We're good? What would the B's look like? What would the last term be? B to the what? Okay, this is going to be B to the 6th. What about the term in front of it? B to the what? 5th. Leave a space for the A, but there would be a B to the 5th. There would be a B to the 4th. I'm leaving a space to fit the A in because that's the trickier part. Let's get the A's now. On the last term, how many A's would there be? None. Then, in the term in front of it, A to the what? 1. A to the? Okay. Let's see if we can carefully plug and chug and substitute stuff in. What is 6 choose 4? Sorry? 15? And then there's going to be a 3x squared to the what? See it? Caitlin, to the 2nd? Yes? Because it's a squared, but a is 3x squared. So it's going to be 3x squared all squared. And there's going to be something to the 4th, 2y to the 4th. Plus. What is 6 choose 5? There's going to be a 6. Something to the 1, something to the 5th. What's to the 1? 3x squared. What's to the 5th? Plus, I'm pretty sure I've started to memorize 6 choose 6 is just 1, yes? And then there's going to be something to the 6th, what? 2y to the 6th. Ellen, you okay with the setup there? We've got to be very careful because it's easy to make a mistake. Now, let's carefully, with brackets, Roy, let's see if we can do all the numbers in one fell swoop. Let's see if we can actually get to the final answer in one less line than the previous one. I think we can. I think we can. Here's what I see here. In the first term, what's the first thing you see, Jordan? First number.
15.
Any exponent on it?
No.
Okay, so 15 times bracket. What's the next number that you see?
3.
3. Is there an exponent on it?
2.
What's the next number you see?
2.
Times 2, and there's an exponent on it? To the 4th? Okay. You with me, Christina? All we've done is we've just focused on the numbers. There's a 15. There's a 15. Oh, come here. There's a 15. There's a 3 squared, and there's a 2 to the 4th. Yes? I guess the coefficient. Hey, what'd you get for the coefficient? If you hit enter, what do you get? Okay, coefficient is going to be 2160. X to the what? X to the what? To the fourth. Y to the what? To the fourth. That's the first term of the last three terms. Let's see if we can get all the, again, do this in kind of one less line. Let's see if we can do the same thing for the middle term there. Let's see. What's the first, in my coefficient, what's the first number that makes it up? You see it, Sebastian? In the middle term there? Yep. Times. Yeah, sure. 3 to the, what's the, okay. I could probably ignore that, but I'll write that just to show you that we did take that into account. Times 2 to the fifth. The coefficient is going to be a 576. Positive? Yeah, because I didn't get a negative here. So positive 576. Sebastian, x to the what? Y to the what? X to the, now, what's the rule when you have a power to a power? You don't add the exponents, you multiply the exponent, right? You add the exponents when they're being times together, but x squared to the 1 is just x squared, or 2. Y to the fifth. The last term. The last term. Ready, Emma? I think we can. First of all, what's going to be the first thing? I guess there's an invisible 1. I'll write it. You can not bother typing that if you want to, but I took that into account. What's the next? Sorry? 2 to the... Anything else? Okay, there's my coefficient. 64. X to the what? Y to the what? Y to the sixth. Okay. I'm going to give you either question E or question F on your test. I'm going to give you some kind of a binomial with some kind of an exponent, and I'm going to say either, hey, write the first 3 or 4 terms or write the last 3 or 4 terms. Okay. How do we write this generically? Here's the pattern. This is what the binomial expansion theorem says if you're using combinations as your shortcut. It says for any whole number n, for any exponent right there, and this, Sean, is what I was getting at. I said you find the great big outer exponent, the n, and your coefficients are going to start with n choose 0, n choose 1, n choose 2, stop when you get n choose n. So if it was an 8, you'd go 8 choose 0, 8 choose 1, blah, 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 8 choose 8. If there was a 15, I don't think I'd ever give you that, but if there was a 15, 15 choose 0, 15 choose 1, 15 choose blah, 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 15 choose 15. By the way, if there was a 15, how many terms would there be when you expanded it? 16. Okay? Oh, and then for the exponents on the first part of the binomial, it's n, 1 less, all the way down to the very last term will be that to the 0 or not showing up. And for the exponents on the B, start with none, 1, 2, 3, 4. And what we want to do now, Connor, is we want to look for a pattern, because the next step is I'm going to say, Brooke, what if I say find the 9th term and just the 9th term? Do I have to write out the first 8 terms to do that? Don't turn the page yet. No. Here's why. Look up, look up, look up, look up. Ready? We want to look for a pattern. In fact, I think I'm going to zoom in a little bit more. Yes, I am. This is the first term. This is the first term. What's the exponent on B? What's sitting next to the C? This is the second term. What's the exponent on B? What's sitting there? This is the third term. If there's a 2 there, what's this? Third term. If there's a 2 there, third term. If there's a K there, what term is this? Think about it. Let's just do it algebraically. I heard it there. Kayvon, well done. K plus 1 term. Now, the thing that's going to, the situation that's going to make this tricky is this. If I want the third term, that's a 2, that's a 2, that's a 2. We have two options. If I say to you, Emma, hey, what's the third term? You could say, okay, I'm going to put a 3 here, and I'll go minus 1, minus 1, minus 1. We're going to choose instead to say, we're going to leave this as undisturbed as possible. We're going to say, if you want, for example, the third term, that's the term 2 plus 1. Sounds confusing. Don't freak out. Christina, now turn the page. This formula is on your yellow formula sheet. Got to give. So for this expansion, the k plus first term, here is the, I'll call it a formula, here is the template for finding a single term. Term k plus 1, and this is on your yellow formula sheet, is equal to, come on, pen, n choose k, a to the n minus k, b to the k. You don't have to memorize that. It's on your formula sheet, but you are going to have to know how the heck to use this, and I'll show you how we use this in just a second. It's far less confusing than it looks. So if you want to find a single term, Rosanna, term k plus 1 is equal to n choose k, a to the n minus k, b to the k. Although usually, I think on your formula sheet, I wrote it without the brackets because that looks less intimidating. Say what, Mr. Dueck? Relax. Let me give you an example. It's much easier with an example. Next example, which for some reason is called example 2 because I started adding a whole bunch of other ones, says find the fourth term in that expansion. Term what? Again, term what? All of you? Term what? All of you right now, write down term 4 equals, because that's what you want to find. You see where the 4 came from? Now, over on the right-hand side, we're going to write out this formula. We're going to write term k plus 1 equals n choose k, a to the n minus k, b to the k. That's right from your yellow formula sheet. It's also right from up there. So you don't need to memorize it. And we're going to turn the left side into this. Now here's the, y'all wrote that down? Term number what?
4.
Term number what?
4.
Okay, listen close, listen close, listen close. Look at this formula. Specifically, I want you to look at this right here. If I want a 4 to appear right there, what does k have to be for me to get a 4 there? That's the key. All of you right now write down k equals 3. This is the adjustment, this is the tweak we have to do to our template. And the reason is because we start counting at 0. By the way, what's sitting where the a is in the binomial? You already know this. X. What's sitting where the b is in the binomial? -3. What's n? Sean, what's n? The great big exponent outside the brackets.
9.
If you write out this formula, if you write down the term number as a subscript, you can clue in, oh, I got to subtract 1 to get the k, and the rest is going to be plug and chug. Watch, 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 watch. Term 4 equals, I got my equals, n. Qu'est-ce que c'est? What's n? Let's all write down 9, choose k. What's k? 3. A. x to the power of n minus k. In your head, looking at the numbers there, what is n minus k? 6. B, negative 3 to the power of k. That there is going to be the fourth term. Once I simplify, once I do the chooses, once I get rid of multiply all the exponents, and that's the fourth term. So let's see if we can keep going here. Term 4. Hey, what is 9 choose 3? What is 9 choose 3? 84? X to the 6th. Hey, what is negative 3 all to the 3rd power? Sorry? Do we have numbers in more than one location? Do we have numbers in the front and numbers at the end? You know what? We can tidy that up. What's term 4? The fourth term is going to be 84 times negative 27, negative 2268, x to the 6th. That's the fourth term of that expansion. If you were to FOIL that out, I guarantee you there's your fourth term. Negative 2268, x to the 6th power. Let's try another one. Example 3. What term do they want me to find? Sorry? What term do they want me to find? What term do they want me to find? What term do they want me to find? Let's all write down. They want me to find term 8. Oh, and let's write down this huge funky formula that helps me find a single term. Let's write down term k plus 1 equals n choose k a to the n minus k b to the k. There's my template. And the key to doing this, for me to fit this blue equation into the left-hand side, what does k have to be? Roy, what's n? What's a? What's b? By the way, the second part of this question said how many terms are there in total? How many terms are there in total? 13, gonna be right? Exponent of 12 means you'd have 13 terms because you start counting at 0. All right. Let's carefully plug and chug. So it says n choose k. So over here on the left, I'm going to write what choose what? 12 choose 7. What to the what? What to the what? X to the Seb. Yep. And minus k, right? Don't overcomplicate it, but just be very careful. Follow the instructions literally step by step. That's going to be a 5, n minus k. What to the what? 2y to the 7th. All right, let's keep going. The 8th term is going to be, what the heck is 12 choose 7? 792, is that right? Okay. 792. There's going to be an x to the 5th. There's going to be a 2 to the 7th and a y to the 7th. Because that exponent is on both of those. right? Hey, I got more numbers I can simplify. I think the coefficient is going to be 792 times 2 to the 7th. I think the coefficient is going to be 101,376. What did I say? 101,376. And then there's going to be what to the what to the what? X to the 5th, y to the 7th. That is the 8th term of that expansion. Turn the page. Is that okay? Foster, yeah?
Yeah.
Got it? Turn the page. Let's try example 4. What term do they want us to find? What term do they want us to find?
Hi. What time do they want to Hi.
So what am I going to write down, Sean? And then over off somewhere in the right, copying from my yellow formula sheet, I'll write term k plus 1 equals n choose k, a to the n minus k, b to the k. By the way, how many terms are there in total, the question asks. How many terms are there in total here? 8. Fill these in on your own. K equals, N equals, A equals, B equals. What did you say K was? K is 3, not 4, 3. For the 4th term, K is 3. This is the tweak we have to do because we start counting at 0. Is that all right? Okay. Start plugging and chugging. Yep. What does it say right here? Can you read to me underneath the T? But I want it to be a 4. What would I put there to get a 4? Guys, stop that, please. Sorry? 3. That's where the K is 3, right? Okay, on your own, see if you can take it the rest of the way. I'll do it up here, look up if you get stuck. But see if you can plug and chug it the rest of the way. See if you get that. I think I'm right. Yeah. If you go, Ellen, systematically, very step by step, it's not too bad. It's complicated plug and chug, but it is technically plug and chug. Complicated. But you'll notice, especially those of you that have me in physics, my love for shortcuts vanishes here because it's so easy to drop off a negative, or so easy to miss putting an exponent on a coefficient on a number, or so easy to, lots of room to make mistakes. How many of you got that okay? Oh, excellent. Let's skip example 5 then, and let's jump down to example 6. Example 6. I like example 6. I like example 6. Example 6 is a nice question. So is example 7. What do they have in common? What am I asking you to find here? Let's look at example 6. How many terms are there grand total in example 6? So if there's 13 terms, think very carefully, what number is the middle term? Term number what? This is important. If there's 13 terms, think very carefully, what term number is the middle term? Term number, Jordan? 7, not 6.5. No. You have 6 terms to the left, 6 terms to the right, term 7's in the middle. That's how you get 13 terms. This is asking you to find term 7. Hey, by the way, look at example 7. Look at example 7. How many terms are there in example 7? 11. What's the middle term number then? Term number? Okay, example 7 is saying find term 6. Example 6 is saying the middle term, find term 7. You see how we can find the middle term? Now that you have this, you would then go term k plus 1 equals n, choose k, a to the n minus k, b. You would write down that little template. Don't think so. Look at the handwritten one, not the typed. Yep. By the way, what's k? Because this is the tricky part. What's k here? K is 6. Right, Brooke? Because if I want to get term 7 and it's k plus 1, what would I put right there to get a term 7? K is what? 6. What's n? What's n? Yes. Christina, what's A? X. What's B? Okay, we're not going to go any further because most of you said you got the last one correct. So you've got the hang of the plug and chug. I'm not going to actually take this any further. You're going to do something like this in your homework. But in your homework and probably on a test, I may say, find the middle term. Because that combines two things. That combines you knowing how many terms there are and using this. Okay? So example 6, example 7 we're going to pass. What's your homework? All of these except, you're not going to get it done in class today. On Wednesday, we are now done the unit. On Wednesday, I'm going to be giving you towards the end or in the middle of the class on Wednesday a huge uber mega quiz. This is the one that I promised you guys that I said was my old unit test when I used to do this in Math 12. That's going to be due Friday. Also on Wednesday, I've already given you a huge review. I'm going to go through there and say which questions are fair game, which questions aren't. Right now, I'm leaning towards your test being a week from today on Monday. Okay? Or possibly Wednesday next week, but right now I'm looking at Monday. So for the remainder of class, my angels, joys of my heart, lights of my life, you can work on this here. So find the first 4 terms of those. And I don't have an answer key. We will go over the answers to this a bit next class, or I'll have an answer key made for next class. I've just noticed I don't have an answer key. I'll have to put one together. There's 15 minutes left. Get a good head start on this. Don't go all loopy on me. Thank you.